So trigonometry in grade 10 was to do with these right triangles and the similarity of these right triangles. So when we looked at the right triangle, we have an angle theta, and we reference the sides relative to that angle theta. So we have an adjacent side, which is next to that angle theta. We have the opposite side, which is the opposite to the angle theta, and we have the hypotenuse, which is the longest side. And we reference these trig ratios using those sides. So the cosine ratio is adjacent compared to the hypotenuse. The sine ratio is opposite compared to the hypotenuse. And the tan ratio is the slope, or opposite over adjacent. So these ratios are just another way to describe the angle. Okay, so when I tell you that the opposite to adjacent ratio is 1 to 1, it gives us an indication of the angle of that triangle, of that right triangle. And slope, since tan is slope gives us angle as well. So we use these ratios to help us convert from, and we need our calculator to this, but to convert from angle to ratio, and then to help us solve for unknown parts of triangles. So that's what we're going to focus on here. So we're going to focus on working with these angles and coming up with ratios and then solving triangles. So when we talk about the sine of 33 degrees, we need to take a triangle, the calculators, and work out the translation of what is 33 degrees in terms of the sine ratio. Okay, so 33 degrees, we have an idea what that looks like. We want to figure out what the opposite to adjacent ratio looks like when we have 33 degrees. Okay, so what I do then is, in my calculator, I do sine of 33 degrees, and I'm going to get, so sine of 33 degrees is 0.54, and I'm going to round that to 5. And again, this is my calculator translating this angle from an angle to a ratio, which also describes essentially the angle of that triangle. So if I want to find cosine of 58 degrees, I do 58 degrees cosine, and I am going to end up with approximately 0.530 when I round that. And again, that cosine ratio gives me an indication of the angle. So if I have my adjacent side is a little bit more than half of the hypotenuse, okay, I get an idea of what that angle is going to look like. Okay, and that's going to be that same description of 58 degrees is going to describe the same triangle that this ratio of 0.530 describes. So I do tan of 45 degrees. Well, the opposite to adjacent ratio of a 45 degree angle is, we don't really need a calculator for this because we know that that slope is going to be equal to 1. And that slope of 1 describes the 45 degree angle. So when we want tan of 88, again, 88 degrees is a little bit harder to kind of figure out what the tan ratio is, but we have an idea what that looks like. So we're going to take 88 degrees, take the tan of that, and I end up with a rise over run of 28 point, around that to 6.4. Okay, so this rise over run ratio of 88 degrees, and that's really steep. Okay, so that's going to be a really steep ratio of 28.64 rise to a run of 1. And again, just try to appreciate that these ratios give us an idea what the shape of the triangle, the same as the angle. And all we're doing here between these two is just translating, using your calculator to translate between the angle to the ratio. Same thing here, angle to ratio. Now, sometimes we want to do this in the reverse. So we need to use an inverse operation. So the tan function converts the angle into a ratio. But sometimes we see the triangle, we know the side length of the triangle, we know the ratio of the triangle, we want to figure out what's the equivalent angle for that. So we need to use an inverse trig function. Okay? So if we are going, what we're doing with the primary trig functions is we input an angle, we tell the calculator an angle, we tell it to put it into sine, cos, or tan, and the output is some ratio. So that's what we did up here. My input was an angle of 33 degrees. I wanted the sine, and the output was a ratio of 0.545. Same here. I start with my angle of 58 degrees. Okay, I input it into the cos function. My output is a ratio of 0.530. Again, it's implied that the adjacent side is 0.530 and the hypotenuse is 1. There's always two numbers in a ratio. The other number that's implied is 1. So this is using the sine, cos, and tan, and that gives us ratios. But sometimes I want to go back the other way, and I need to use an inverse trig function for that. And so the inverse trig functions are when we start with a ratio and we go backwards and find the angle. And those functions are called the arc sine, the arc cos, and the arc tan. Depending on which ratio you start with, you use one of these inverse functions. So basically, these inverse functions allow us to start with a ratio and go back to an angle. So if I input the ratio, my output is the angle. And these inverse operations we call arc sine, arc cos, arc tan. They do the opposite of sine, cos, and tan. So in these situations here where we have the ratio and we want to find the angle x, well, I need to be able to use the inverse operation. And most of us have used this before, but we also want to start using the notation for this. And we want to start using the inverse sine notation. So the inverse sine notation is going to look like this. This has an equivalent inverse expression that looks like this. Inverse sine or arc sine of the ratio is equal to the angle x. And these two expressions are equivalent to each other. One is in the sine form, the other one is in the arc sine form. Okay, just like we can express every equation, times equation, with a divide. Okay, so if I have 3x equals 2, I can express that with divide by 3. Okay, same with any expression, any operation can be expressed with its inverse. So in this case, these are two equivalent expressions. One is in the sine form, the other is in this arc sine form. And using this arc sine form, we're just going to solve for x. So we start with 0.342, and we're going to do the inverse sine, and we get 19, the angle x is equal to 19.99, so I'm going to round that to 20.00 degrees. Okay, so same thing here. We want to write this, we don't know the angle, we have the ratio, so we want to inverse, do the opposite of cos, so we need to use our arc cos. So I'm going to write the arc cos form first, and then apply the arc cos. So here I'm going to solve for angle x, and the angle x, I do 2 divided by 3. I'm going to do the arc cos of that, and I'm going to get 48.19 degrees. Okay, so my input is my ratio, my output's the angle. What's new though is that we are now expressing this using the arc cos as an algebraic expression. Okay, so that's probably new to you, and this is something that we want to start doing.